Hey, Garrett, welcome back.
Yeah. Hey, good to be here again.
The most important question today for me, thought about our conversation last time, is do you like Star Wars or Star Trek more?
Star Wars.
Star Wars, okay.
Yeah.
Same here.
Clear answer.
Clear answer. Okay. Actually, the last time we discussed the JavaFX and Swing, and you said, okay, this JavaFX and Swing doesn't work at all, and you forgot how it works actually, and this is why you focused on server-side Java, because the entire Java frontend is a lost battle, and you don't care anymore, right?
You nailed it.
No, but regarding JavaFX and Swing, I think it could actually come back a bit, right?
Yeah, probably. I mean, it never was really gone. So I think I mentioned that last time. Because I worked for a couple of years in consultancy, and it was mainly desktop Java. And it's used widely. So it's just not visible to the public. It's used in big companies, insurance companies, banks, or industries. They use it internally because it's so easy to use for internal applications, sometimes really big ones. And sometimes even not allowed to use a browser application. So they just need to do something on that machine. So native, more or less native stuff. And you will find it quite often in big companies. I was surprised. I did a session about that a couple of years back, like not dead yet Java on desktop, because I was surprised myself how widespread is still used.
No, I mean this was always clear that big companies do strange things. But I mean, if you consider Flutter, for instance, stuff like that, right? This is also native technology, and it is similar to Swing or JavaFX. Basically, they are rendering everything in a canvas.
Yeah.
So what I mean is, for Java developers, instead using Flutter, we could actually use JavaFX, and if the pipeline is streamlined, that we ship everything to the app stores as well as in desktop, this could it could actually take off, right? Because I mean, for Java developer, it's a way easier to create JavaFX or Swing than playing with Flutter. I mean, Flutter is really nice, and I like Dart, but the entire installation process is crazy. This is like you have to download several gigs of something, right?
Yeah. So but you mentioned Flutter. I didn't get the whole sentence. So you just said it's.
So I mean, the Flutter it is implemented in Dart, so it is actually a nice developer experience. But the problem is the entire installation is not easy, and for Java developers, if you have a modern Java 21, it could be actually really nice to create Java with Swing or JavaFX, with the listeners as lambdas, and use modern Java, and then use GraalVM, similar technology. It could be J-Link, JMod, or whatever to create a nice image and ship it to the app stores, right?
Absolutely. Yeah, you can do. I think the problem is more that it has this negative image.
Exactly.
To Java developers. I don't know where that came from. Maybe from the past where it was not very fast or whatever. But
I can tell you why.
Okay.
Swing first, right? The Swing, there were lots of developers who create pink Swing UIs with golden buttons, right? This was I was one of them. Then the next problem was then Swing was the entire time told to be slow, sluggish, and not native, which is also not true, but this is how the perception is. And then JavaFX script started, right?
Oh, yeah.
And people thought, JavaFX script, why Sun creates a new language if there is Groovy. There was entire discussion about that, but it died after 1 year, and now we have pure Java. But people forgot about the positive things, and they still think about the legacy and old stuff is the same. Like Java E, they think they're slow because WebSphere was 10 years ago slow, right? So this is WebSphere Classic. This is exactly the same idea. And what I was wrong a bit, because I thought, okay, if Oracle is no more behind JavaFX, then it should die. This was my personal opinion, because what I always was afraid about is the cost of porting JavaFX to ARM. So what I saw ARM on the horizon, and I said, okay, now if there's an Intel, I think it is impossible to a small company to migrate the JavaFX runtime to different platforms. And I was proven. What I absolutely forgot, is Johann Voss, because what Johann did, he already ported Java to Linux, right?
Yeah.
And I completely underestimate, his capabilities, and I was proved wrong. So actually a small company can port Java, and for years he maintains and patches JavaFX which is great. It's still a small company, but it works, right? So,
Yeah, it
and I would
works.
say from strategic perspective, I would actually rely more on Johann Voss company than Google, right? Because Google was not really
Yeah, totally agree.
predictable, what survives and what not. So, so from this perspective, if you forget, the JavaFX and terrible Swing UIs 20 years ago and whatever, it could work. And what you proven with SteelSeries and IntelliJ with IntelliJ and the other API, Swing looks great, is really fast. And actually, IntelliJ indirectly by WebStorm and DataGrip and the how it's called, the Python environment.
PyCharm, right?
PyCharm, exactly, is used by non-Java developers. I never heard any complaints that IntelliJ is slow, actually.
Yeah.
And I used IntelliJ. I used less, but what I did is I started NetBeans once again, right?
Mhm.
And what was surprised how responsive NetBeans is and how fast it is comparing to Visual Studio Code. So I use Visual Studio Code all the time. No, it is actually slow. And if I launch NetBeans, and everything was immediate, and this is Swing, right? So this is interesting, right? Because right now I use Visual Studio Code because of my laziness, but I'm surprised how fast Swing actually is. So I would say I don't know what to do, but it actually should take off. Whether it will, different story. But not it could, right?
But this is exactly the reason why companies choose Swing applications over this Electron stuff, because it's really fast. It is. So it's surprisingly that it has this image not being fast, but it is really good. So and I think that's the reason why IntelliJ still uses it, right? So they could have changed to something different. They're probably big enough, but they don't do, because it seems to work quite well.
Yeah, this is exactly like, it's crazy because I started in Java. I'm actually wondered why I'm speaking with you at all, because you are no late starter with Java 1.4. Usually, I invite only people with JDK 1.0 and 1.1 experience, and you came, 2 years ago, right? This is,
to be honest,
with Java 1.4. You started with Java 1.4, but if you, as what I remember at the beginning, I was constantly told Java is slow and we cannot use in production because it's slow. So, and then was nothing. And then came the other argumentation. This is, I don't know what they remember, on all conferences, Java is incredibly fast, but it is a low-level system language. And we should not use Java as a system language. You should use Groovy and Scala instead. It doesn't matter that Scala and Groovy are slower because Java is just too fast. And I say, okay, this is interesting, because I do just Java. At the beginning, it was slow, and now it's too fast, and I do nothing else in Java, right? And also the clouds, right? So so Java is not cloud native or whatever. And I found a paper in Java is number 5 regarding to energy efficiency and performance. It is like C, C++, Ada, Rust, and then Java, and Go, Ruby, and everyone else. Is this as a Python is 35 times versed in Java. So, and this is a crazy argumentation all the time. And Swing was the same, right? Constantly, it is sluggish, and we have to use SWT on whatever. And now it is like the secret weapon. Yeah, we use Swing if it has to be fast, and if it can be crap, then we use no Electron or whatever, right? So this is like.
And people are surprised when you say to them, "Oh, this is basically Java Swing," and then really. Wow.
Yeah, how to learn it, right? So.
And to be honest, I was thinking about going back to Swing because this still comes with the JDK. I really like that. So this is what I never liked with JavaFX. You have to do an additional installation, or you have to come bundled with it. That is a little bit of a hurdle. So Swing is nice because it comes with the JDK. That's pretty nice. So
I also have the short series on YouTube, and I also thought maybe you should start a little bit with Windows, because. Windows is a window, open a JFrame, because sometimes we need a small utility, right? I do CLI a lot, but sometimes it would be nice to have 2 buttons in a select box or something like this. And for that, this is crazy fast. So for utilities. So
it has a future. So I'm still promising it will be there even in 15 years from now.
Exactly. It's not like Oracle, or it's impossible anymore. And then now Azul, it's not like they don't mark the Swing as optional whatever module. But I think now we have Azul and we have the others, right? Okay. Now, just recap your transition from the beautiful, colorful Swing world to black and white Azul backend stuff. So Martin Ritter asked, no, Martin, Simon Ritter asked you, right, about Azul.
No, it was actually Gertjan Vilenga.
Gertjan, exactly, Vienga.
He pinged me and asked me because they have been looking for someone. But Simon was there already. So
Okay.
I knew, because we worked at Oracle together, he was my manager at Oracle in the Java evangelism team. And then he left Oracle and moved to Azul. And I left Oracle half a year later and then went to Karakun, or Canoe at that time. And then I was working there for some years. And then Gertjan asked me. And I knew Gertjan was there. Simon was there, which is not just a colleague, is a really friend of mine. So, and I was, yes, I absolutely would love to go to Azul.
But Gertjan is a bit crazy, right? This is now absolutely about Azul. He's like, now he was always, as a NetBeans, he was completely into NetBeans and now completely into Azul. So he's like,
He's 100%.
Yeah, 100%, 110%,
right.
He would like to make now the Fujay and Azul absolutely successful. Yeah, Fujay, exactly. Friends of OpenJDK, right?
Exactly.
So, okay, so how you started with Azul? What is your first impression? So, what's also always interesting, what you did the very first week at Azul?
The very first week, I was reading a lot. Because to be honest, when I started, I had an interview with Gil Tini, which is the CTO and one of the founders. And it was a 3-hour interview session. And after that, I was like, wow, there's so much stuff that I never heard of, which is one of the problems that we still have, because we didn't do good in marketing for around 20 years. So that's the reason why nobody knows us. But Azul did quite some stuff in the Java environment that I wasn't aware of. And so I read a lot about the different JVMs that we have and all the features and the history of the company, which is quite interesting. People usually don't know that Azul is already existing for more than 20 years now.
Yeah, and now I tell you why I'm completely disappointed of Azul.
Yes.
So, because it was Java 1, I don't know, I think it was probably 2006 or 2007. I have a blog post, but I forgot to look it up. And at Java 1, Azul presented the Vega machines.
Vega 1, yeah.
Vega 1, and they were like host machines, which were optimized for Java. They look beautiful, and I like such a stuff. Now, I was also impressed by the Silicon Graphics machines back then, and Azul was something similar for the backend with custom chips. And what I also heard, the Java 1, like manager was completely excited and called Germany. There is an hardware which runs Java natively. We have to buy it like 50 cores or whatever. And it was incredible. Back then, it's like the machine had 50 cores, which for that time was incredible. And this was Vega 1 and Vega, there were multiple Vegas, right?
Yeah, in 2008, I think, there was the Vega 3, and that came with 54 cores, and it was 90 nanometer process, which is today, that's really old stuff. But at that time, it was really high-end things, and it came with 768 or 86 gigabytes of RAM, and the heap was able to manage 600-something gigabytes. And at that time, in 2008, that was just amazing that this is even possible to do garbage collection stuff in this huge heap without pauses, right? That was very impressive technology.
And you know how it happened? I will have to interview someone from Azul that they
created. It's interesting because I can just tell you the story that I heard from journal people. So it's Gil came across the problem with the JVM, right? The garbage collection process, which was and still is biggest problem, the stop the world garbage collection process. And he was thinking about how to solve that. And one day he solved the problem of doing pauseless garbage collection concurrently all the time during your application is running. So he solved that. And then they figured out that they need to do, because if you do garbage collection at the same time where your application runs, then this drags down performance a little bit. You need CPU to do that, right? So they implemented everything in hardware, or let's say they built hardware to support that garbage collection process better, because the other founder came from 3DFX. You might remember the Voodoo FX graphics card. This is the other founder that we have.
I had the Voodoo card actually
me too. So it's Scott Sellers. He worked.
This was the OpenGL. This was one of the first OpenGL cards, right?
Yes. Yeah, and it for some time it was the card that you need if you.
Yeah, and the name Voodoo, alone the name was cool.
Exactly. So yeah, this is the other founder. So and then both of them came to the idea we have to build our own hardware. So Azul started as a hardware company.
Mhm.
And then at one point they figured out that that's all good, but you can't keep up with hardware development. It's very
Yeah, but
expensive.
what's amazing back in time that we were able to fab the chips.
Yeah, it was produced by TSMC. So
Yeah,
that was
that doesn't
because
matter,
Scott
but
had all
still.
this. Yeah, because Scott had all these connections, and he did that at 3DFX, right? That was his company. But
Ah.
yeah, so it was a good join with Gil and Scott, and there was a third one. Can't remember the name. Three founders,
Mhm.
and then so they decided to go that route. But at one point, figured out, okay, we maybe should switch to software completely, right? So
Mhm.
instead of building hardware, because this is really tough, and then competing with Intel, AMD, and ARM and stuff, it's just these days not possible
Yeah.
anymore. So then they decided to do software only.
And this was where I became disappointed because I was like, no, this is, and I found the post. The title of the blog post is "New Hardware for Server-Side Java" from December 2006. So I
Yeah.
will put this to the show notes,
Mhm.
and it was a 48 core Vega CPU.
Yeah.
The link doesn't work anymore, and there were verified applications. But I was disappointed back then. There was no Glassfish because I use Glassfish all the time.
Yeah.
But this was the second, and I saw it again at Java 1 later, and what I also wrote is that it consumes 1,000 watt of power, which is nothing today, right? I mean, this is like, and I was like, okay, yeah.
Yeah, that's interesting. So, like I said, the story is quite fascinating to see that it started as a hardware company and then went to software and then built everything in software, which is
This was Zinc, right? This was.
thing, right? This is the
Mhm.
JVM that we did, which is also interesting product because first of all, we have the C4 garbage collector.
Mhm.
It's continuously compacting, collecting. I don't know C4 four
Yeah,
C. That is
yeah.
concurrent. I'm out.
Concurrent compacting, maybe.
Yeah, concurrent compacting continuous collector, something like that. This is the
Yeah.
name. So and then they implemented that in Zing, but then it comes with the problem that I already mentioned. If you run stuff in software that continuously in parallel to your application code is doing the garbage collection, then it really brings down performance because you need some part of the CPU to do
Mhm.
the garbage collection stuff. So what they then figured out to go back to the same performance, we just exchange the compiler within the JVM, right? We take out, you have the execution engine in the JVM, which is one part besides memory and class loading subsystems. And in the execution engine, you have the interpreter, and then you have these tiered compilation compilers
Mhm.
like the C1 JIT compiler and C2. And the C2 is the specific one that does all this speculative optimizations and all these things. So this is the one that produces the final code that is really fast. So we just took out this compiler and wrote our own compiler that is
Mhm.
based on LLVM. This is a compiler framework, which is
Wow.
yeah, that's mainly driven by I think Apple, Intel, and
Exactly.
other
So
big
what I wanted
companies.
to say, this Swift also runs on LLVM. So what you could actually do is you could potentially take it and make it Swift compatible or something, right? So
Yeah, in principle, it's we take that technology. It's really a compiler framework, so you can
yeah.
build compilers using that, and that's what we did. And at that time, it was like, no, you can't use LLVM to create a compiler that's running in the JVM. So, and we did that.
Mhm.
So, and this compiler is way faster than the C2 compiler. So it can, the compiled code can be up to 40-50% faster, depending on the application. So it's not for every application.
Mhm. Which applications benefit the most?
Kafka, Cassandra, these
Mhm.
are really, we have very good results there. So it's sometimes just by replacing the JVM, you get up to 45% performance increase just by doing that without
Performance or
doing,
throughput? I mean, like
this is throughput. Yeah.
throughput.
This
Okay.
is, yeah. So it's really interesting to see that. But this comes with another drawback, right? So we solved the problem with the garbage collection and had the problem. Now we have not the same performance. So we created our own compiler, which is better. Now we get back the same performance. We get a new problem, which is because of this aggressively compilations and optimizations takes a little bit longer to warm up. Means we have a problem that the warm up time of your application takes longer. So we created another project which is called Ready Now. That
Mhm.
means you have your compiler and that starts compiling first interpretation for some time. It's method counting and loopback edges. And then once it gets into C1, you have the same, maybe 5,000 times in JDK 17. And then it goes into the Falcon compiler. and does all the compilation. Takes some time to get there. Once it's there, it's fast. But the JVM doesn't have any memory, right? So it means the next time you start your application, you have to go through the same thing again. And that's what people say Java is slow, because the startup time isn't the fastest one. So what we did is, first time you start your application and you run through all these optimizations and de-optimizations, we just save all the latest optimization step. In principle, very easy to speak. It's way more complex than that. And then the next time you start your application, instead of going to interpretation and all these things, as soon as a method is called, it will just take it from this file and say, oh, this is the way I should optimize it, because that was the best optimization possible. So you don't have to go through all the optimization process, which takes some time. And so we can optimize perfectly fine the first time you do a compilation. And this saves all the warm-up time. Right?
So what you're doing, you're like pre-training the application, so you're invoking.
Yeah, it's like a profile of the optimizations and the.
Do you have to run a unit test or whatever in order to do so? Or
this is internal. We just save, because the compiler is doing that anyway. We just save the latest for each method in an easy speak. And then the next time, but you still have to compile it, right? So we just save the try and error thing, right? So I optimize it in this way. Oh, it doesn't work. I have to de-optimize. Oh, no.
Exactly, because the hotspot, what it does, it optimizes and de-optimizes, because it assumes something and then optimizes for the assumption, but sometimes it doesn't work. So it have to revert the optimizations. And what you're doing, so you're doing this in advance.
Exactly. So we just tell the compiler, you don't go that way. If it's this method you use, then compile it like this. This is the best way to do it, and that saves a lot of this de-optimizations.
And how fast starts it then? So what is the improvement?
The start is, in principle, you can get. It's not about the starting time. This is about warm up time, right? Because you that's a little bit interesting. If you have my crack session, I have people really educate about JVM startup and JVM warm up, which are two different things, right? Startup is you start it, how fast, what's the time to first response?
Yes.
Doesn't mean this is fast now. This is just the first time your application came back. But once it's running and continuously running and you apply some workload, it gets faster and faster over time. That's the warm up time.
Yes.
We save with Ready Now, we save warm up, because we know exactly this is the fastest stuff we can do. We still have to compile it, and that takes time for the first time, right?
But usually the startup is influenced by what I'm surprised you said there are 4 tiers, at least in hotspot, right? There's interpreted mode, then is the somehow optimized, and then is the highly optimized, and then we have the machine. So there are like 4 tiers, and you replace all the from 2 to 4 with your Azul.
Yeah, we just compile it, and then it's in the code cache, and then after it's compiled and in the code cache, you take it from the code cache.
Yeah,
this is usually what's happening, right? So that's the final destination, is the code cache, and then from there you get all the compiled code directly.
Yeah. So what you are optimizing, so it means the warm up. It is warmed up. It means you get peak performance immediately.
Yes, exactly. That's
and the startup time is like something is responding right now, right?
Exactly. So and it takes still some time to compile everything. First time you have to do that, right? So that it doesn't mean...
But I think you get still a optimization, because what I do in serverless is we are deactivating the optimizing compiler.
Yeah, you just use C1.
Yeah, exactly. In order to have a fast startup time, right? Yeah. But in your case, what it will mean is I could get the same startup time with peak performance, right?
Yes.
Because but then I could...
The startup time, yes. It's probably...
So with Azul on serverless, I would get peak performance with the same performance without any negative impact on my current startup time.
Yeah, probably, yes. So I never really tested it in serverless. It would be interesting to see how it works there. So,
You don't have to test it in serverless, because you can have a custom runtime in serverless. So you could just test it on your local machine.
Yeah, that's true.
But we are speaking. Actually, it doesn't matter a lot. It only matters under high throughput. This is where the costs, you will see a difference. Because from the user perspective, whether something executes 20 milliseconds faster or not doesn't matter. But aggregated costs is a lot, because it can be 10-15%, cost reduction, which can be huge.
That's the interesting part that people don't really get when I tell them the compiler produces faster code, right? They say, oh yeah, but I don't need the performance. Well, you don't need the performance, but if you can do the same performance with less CPU, then you can save a lot of money in the cloud. Right?
Yeah.
Because if you run 100% on OpenJDK, and you can do the same with 60% of the CPU nodes running, for example, Zing or Prime, how we call it now, then you save 40% of cost. And this is something which is really interesting for companies.
This is now for boring cloud loads. For serverless is even step further, because in serverless, what happens is on AWS Lambda, for instance, you have to buy the CPU with RAM.
Mm-hmm.
So if you would like to have one CPU, which is reasonable in Java, I know it is roughly 1.8 gig of RAM. So you're buying 1.8 gig of RAM, and this is the fastest and cheapest, usually, option for Java. So now you don't have to save the CPU. You can fully use the CPU, because the more you use it, you paid already for the CPU.
Yeah,
but now, the only thing which matters is execute as fast as possible per method. So if you manage to execute fast, you save money.
Exactly.
This is the entire trick. And if a method executes 10% faster, then you save 10% money. So whether it's 20 milliseconds or 1 millisecond, no one cares. And this starts to matter in the last 5 years. So I would say since Corona. So we have more and more, cloud workloads. And what I usually tell on my conference talks is that clouds without cost do not matter, because I could just buy a huge machine, put everything, and I'm done. So the entire architectures only matter if you consider the costs. If you have endless budget, who cares about performance? And this is where it becomes interesting, because I'm constantly thinking, okay, startup time once until the AWS Lambda is warm is just user convenience, because it happens only once. If it's warm, now it has to execute fast to save money.
Right.
And this is why, for instance, we don't use GraalVM a lot, because I would save, the first startup, which is maybe annoying, but in enterprise apps, everyone is happy if the application starts at all. I mean, this is everyone already happy if after 2 seconds something happens, and then if we can execute fast, we can actually save money, right?
Yeah.
And this is why I'm asking you. So this is I would say in clouds there are 3 architectures, I would say, or 2 makes only sense from my perspective. If you are really into costs, I would go either with bare metal or with serverless.
Yeah.
Running something in containers is like, lift and shift. I have something on premise. Management would like to run in the cloud. I go to the cloud, but no one knows why, right? So this, but if you have to. But if you have high traffic, then go, bare metal, EC2 or whatever, because you know what they are doing. And then I would already now seems like an interesting solution. Startup time doesn't matter, because you have enough time to warm up or whatever. Lambda completely different. Throughput, no one interested. I have just one CPU, right? So the scaling model is per CPU. So that the main difference is on Kubernetes, you have multi-threaded application. Loom matters a lot. Bare metal a lot. In Lambda, not at all, because I have one CPU, one thread. You have 1,000 processes. I have transactions. I get 1,000 CPUs working for me, right? In parallel. It's a complete different profile and complete different cost structure. So, and this is interesting, that I would say what I would expect more tweaking in this area. But if I, if I talk about that, people say, okay, we don't care, or no, someone else is responsible for the budget. But it already changes right now. So it could be a huge opportunity for Azul, because what I already see for some of my clients, the cloud becomes so expensive that they think about, what they can do right now. We should come back, but we already sold our data center. There is nothing there. So what to do? And I would say just, lift and shift, just rent machines and run and hope this won't work.
Yeah, and you see that, right? Even big companies do that these days, going back from cloud to on-prem, because it's just, for them, it's just cheaper. Yeah. And you don't need to have this cloud. Everybody, it is this hype-driven development again, right? Yeah. So you have to go to cloud, yay! And then suddenly, oh, damn it, it's really expensive.
I don't know whether you attended my WJAX talk. You attended?
No.
So I saw, basically Raspberry Pi, Postgres on Raspberry Pi would cost you roughly €300 a month. So so if you go to the cloud, you have two reasons to go to the cloud. And sometimes you have to, right? There are different reasons to go. And if you go, you have to be efficient. But if you have working data center, I would say there's no reason to go to the cloud.
No.
I would be perfectly happy with my own servers. And then what I could do is I could even optimize further. I could use flight recorder. I can use tricks from Azul. I'm less restricted. But what I see, they have own data center and they do exactly nothing. No optimizations. They run container with default settings and completely ignore the fact that could actually be highly efficient, right? Then they say, we have to go cloud. Okay, they pick the same container, running Kubernetes. Now we are cloud native without any optimization that pay 10 times more and everyone is happy. Then after 2 years, everything becomes too expensive. They come back to data center with the same container. And this is a little bit pity, right?
It is. I mean, this is interesting because I see that in the session when I do security and also the one about OpenJDK distributions. I mentioned that you have a JDK and you have a JRE. And since JDK 11, I think there's no JRE.
Really. Exactly.
So we have JLink. And then I asked people, who knows JLink? Maybe 2 people raised their hands. And I said, who's using JLink? Nobody. Really, nobody's using JLink. I was like, people, listen, they take some base image and some people use a JDK inside. Like, this is 340 megabytes just for the JDK to run your service.
Not a base image. I do code review right now for microservice applications. Yeah. Every 2 developers who build their own microservice, they have own base image, Some people pick, from Alpine, the other one, UB8 from Quarkus, the others would like to have, whatever. So if you're a company with 5 microservices, you have probably 6 different images because there are different versions for this is the truth. And the problem is security, because if you pull something from open source, you actually have no idea what you are pulling.
Right. But you know what? In my security talk, I asked people and I just said, you download this stuff. Did you ever ask yourself if it's secure? No, not really. So people just trust these systems, which is shocking. Partly.
And even if it were somehow secure, the problem is the clouds perform usually security scanning, right?
Yeah.
So, and if you pull something from open source, I always have the problem that sometimes it stops and says, some hidden library has some problem and we cannot deploy, which is really annoying. I would say then I would always try, to keep the image as linear as possible. Or why I like serverless, there is no image at all, so I just have the runtime. But to increase the cost, then I can actually push to the repository at all, right? Because usually if you have a big image, you always something is found. Like JPEG library you don't use it at all, but you cannot push because some hidden dependency has a security problem.
Yeah. So people have been surprised when I told them that if you run your stuff with a JDK, then it's 340 megabytes. And if you run it with a JRE, it's 150. But if you use JLink, it can be as slow or as small as 30 megabytes. Wow, what? 30 megabytes for Java? Yeah, sure. But these people are the people that are complaining, Java is so big, it's so slow, but they don't spend the time in really figuring out how to, like you said, I just use this stuff because it's convenient. I never really thought about optimizing it, right? But there's so many ways you can do it better.
This reminds me a story. So I know I did back then, EJBs and really like and I still think is a good technology. But the EJBs in Glassfish, the entire container was, I think it was like 600 kilobyte. It was the entire EJB container.
There you go.
And I was in a project at the use WebSphere, and they asked me for architecture, and I wanted to have the newest Java EE, I think was back then Java 6, and I knew that the WebSphere, we need a new version. And I said, okay, then we just download the patch, no problem. So it is 600 kilobyte in Glassfish, and they say, no, we cannot do this. Like, we do it, and it was 1.5 gig for the same. And this is why they didn't want it to do this, right? And they downloaded it. So like after 5 hours, back then everything was slow. And it's like, what they're doing is like, we downloaded the patch as you said. I was like, yeah, but why it takes so long? And it's like, it's 1.5 gig. For me, back then, it's like 1.5 gig. I suspected there's like a video courses embedded or something, because for me, it is like, all the application servers, the EJB containers were tiny. Yeah. And the WebSphere Classic was 1.5 gig. And I say, what you're downloading, is the IDE included? I mean, this is impossible to imagine, right? This is a similar story to now. Yes. This is why I know, for me, this was different world. Like the WebSphere Classic, this was like, don't touch it. And whatever you do, you need 3 coffee breaks and a really high bandwidth, And all the other servers were small. This was, this reminds me to your talk right now, right? Downloading the entire internet and then complaining that Java is big, right?
exactly. So this is, but people have. I was really shocked because I thought J-Link is something that is in the JDK since JDK 9. People
Mhm.
should know it, but they don't even heard about it. It's like, what is a tool, J-Link? I said, oh my god, what's going on?
You
And then
could ask about JMod. This would be the next question, right?
yeah, exactly. And then they thought, oh, now we don't have a modularized application. I said, no, it's not about your application. It's about the JDK.
Mhm.
What do you mean the JDK? So, oh, we have a modular JDK. So you have to explain them and educate them about the basics that we think it's the basics. But most people don't know that. It's like, yeah, just use it.
On that note, we both were at the WJAX in Munich conference recently, and I showed basically all Java E code, not J2E. Not, 10 years, 15 years, 2011. It was 14 years old code, right? No, 13 years old code. And then I push it as an AWS Lambda, more or less, right? And someone came to me after the talk and I say, how to learn the modern stuff you do. It's like, what do you mean? This is 14 years old. This is like, it's like, yeah, but I really like to do this, right? It's like, yeah, my entire GitHub, is everything, that this old code is harder to find. But if you do a little bit, Java 7021, this is what I do, no dependencies. And he was absolutely delighted that actually it works that way. So story repeats, right? So this is, and I don't know why. Maybe Stack Overflow or somewhere, people find the templates and without questioning, somehow the biggest and most bloated thing survives.
And someone approached the booth and I just told him about JVMs and that stuff. And he literally told me that I'm not interested in the JVM. It should just work. I said, yes, but you need to know where you run it on. And he was like, I don't care. So, you should care. There's a difference. And then I was really shocked that people, I get it that you would like to just do your job and getting things done. That's all good. But this is part of it to me. This is the engine you're running on. And you just don't say, I don't care if it's a Porsche or if it's a Trabant.
The person was right. You don't have to care if you build, I would say, boring software without any additional requirements.
True.
If money starts to count or, memory consumption or CPU, you have to care.
Yeah. And in these days, most of the companies run stuff, like we already said, in the cloud, or at least it's not for free. They don't do it for free.
I think a few months ago, I was in a workshop, Cloud Native workshop. And I also started to know what we do. Usually I start doing a calculator. Okay, we have, we can buy these machines, or we can go Kubernetes or Fargate or whatever. And they told me, just stop, because the budget is paid in another country, and we basically can do whatever we like. This was no kidding. And I say, I was speechless, because in this particular case, I have to say, this is, I'm really surprised, because what we can do right now, because I thought if we just, provision bare metal hardware, then we have to provision more. It's not that easy. If you have unlimited budget, it's still not that easy, because I think, okay, would you like to maintain the machines more, or would you like, just to deploy and see what happens? Because then it's really hard, because I thought you could buy a big EC2 machine, but still they would have to maintain it. Or maybe ECS Fargate is better, because just containers and then have to maintain it. So we went the ECS Fargate route. But I was really surprised. And then I met, the actual manager, and I say, okay, it was not meant that way. They have some budget, but it was not in this department. I said, okay, fine. But it still happens, but it stops. This is what absolute exceptions. But I was speechless. I for a moment, I said, okay, what do you do right now? I have no answer to this question, right? So what do we do if we have unlimited budget, right?
Yeah, this is really a good question.
Yeah, not that easy to answer. How you will tune Azul when CPU and memory doesn't matter?
Wow.
This is not that easy to answer, right?
Yeah, probably because you usually don't bump into the situation.
Yeah.
Yeah, okay. That's funny. But just to come back to your serverless thing and lambdas, right? Because there's another thing that can help here, which is also part of it. Will become part of Zing. Let's stick to the name Zing, because people know that, but it's Prime now for whatever reason. There is this thing called Crack, right? I mentioned that already, where you can also, Amazon has Snapstart, which is basically Crack, but they did a different implementation with using micro JVMs. But in principle, what you do is you start up your JVM once, you create the snapshot or checkpoint, and then you just restore from there. And with this, you can even go faster, because if you combine that with Prime, then or with Zing, with the Ready Now stuff, then that means you can do the best compilation, and then you create a snapshot after that's done. And then when you start it up the first time, it's as fast as 30 to 80 milliseconds, like a native executable, and already has the most optimized code. So that means you get both of it. Very fast startup first time, and keep the continuous high performance directly from the beginning.
This would be a killer feature, because then you could you have the Ready Now, you said this is mainly the
Yeah.
entire, and then use the snapshot to back or to freeze the optimizations.
Exactly. Yeah.
And
And then you
load it
have
from
really
memory.
like memory in the JVM, because the next time you start it, and this is really relying on I/O. It's really loading back stuff from the disk into memory. On an SSD, this is milliseconds. It's nothing. It's really fast.
Yeah, this is cool, because the bandwidth, the file system on AWS is crazy fast, so you wouldn't even notice. This is so the image size doesn't matter at all.
Probably this is not the big problem, right? Because
no.
If you save the snapshot, of course we have a bigger footprint.
I think it is 100 meg, no one cares.
Yeah, and it's around that. So
I would say 100 megs and lots of small files. There's a problem, like Node.js and Python. But if you have one file, 100 megs, it will be crazy fast. I actually was on AWS and I downloaded something big. And I thought it's broken, because it's like 150 megs and it downloaded, I don't know, in 10 milliseconds. It was not noticeable. It's like curl, and it was there. It's like, what? Is it? So it's problems with firewall, whatever. So at the bandwidth in the cloud is crazy, actually.
Yeah, it's amazing. Yeah, and then for this kind of stuff, because people say, yeah, but then I have to load it somewhere from the cluster, maybe, because usually you don't put it. You put it somewhere decentralized and then load it from there, that you don't have it with each image. And then people say, yeah, but this is really not that fast. Believe me, if it's running in the cloud environment, it is fast.
The only problem is, if you what I like about serverless is, if I go to Azure or to AWS, I just say I have Lambda with Java 17, and I don't ship Java 17. I just ship the bytecode. From this start, if I would use Azul for that, I will have to use so-called custom runtimes.
Yeah.
What I thought about, but what AWS also supports is Rust or Go, I think, even on Swift. Actually, we could write in our Rust wrapper, which calls the Azul thing, and then I don't have to have custom runtime. Then I would have a native Rust deployment, which is actually Java, right? So this
that should work. Yeah,
should work, because the custom runtime, what it does, it is basically the container gives you a stream in and you provide stream out, and that's all.
Yeah.
And because the next thing about serverless is security. For instance, what AWS did, they patched, for instance, the log4shell, security in the cloud by a bot. So they did it for you. But if you run your custom runtime, you have to take responsibility for it. But with Azul, if there is a process to do so, this would be also a cool idea, because okay, I don't pay AWS, I pay Azul, and it's done. And many of my clients have Azul support contract, so this would be a possible option, to save money with Azul. And
it's a valid idea. So, and even for security scanning, we also have, of course, we have something there. It's
now what's me really interested today is about Azul. So, what is the flagship product? This is the Zing, which is renamed to Prime right now.
Prime, yeah, this is the flagship product.
And this is just OpenJDK, or what is it exactly?
Yeah, it's based on OpenJDK. Like I said, you take OpenJDK source code, take out the compiler, easy speaking, right? Take out the compiler, plug in our own compiler, and we take out the garbage collectors and put in our own garbage collector, because the garbage collector and the compiler work hand in hand. So it's very much involved in each other. So you can't just do it without the others. And this is more or less what it is. And then it's still TCK compliant. So
if I pick the Zulu JDK, is it this exactly, or is it just
Zulu is OpenJDK. This is a vanilla build of OpenJDK. We have some features in it, additional stuff like track or Azul vulnerability detection. This is in the JVM, but it's basically a build of OpenJDK. Yeah, that's Zulu.
So if I pick Zulu, I get OpenJDK, a little bit better than vanilla OpenJDK, but still OpenJDK, right?
It is OpenJDK, absolutely 100%. So there's no difference, and it also passes the TCK and the Aquavit test suite. And it has features that we can enable. So if you use the free version, which is free in production forever, then you just have basically vanilla plain OpenJDK. If you then buy a support contract and you
Yeah.
buy, for example, Azul vulnerability detection, then you can enable a switch, and then
Okay, which switches are available in OpenJDK?
not in the basic one. This is only in the Zulu builds.
In the Zulu.
Yeah.
Yeah, which switches are available in Zulu?
There's this Azul vulnerability detection.
Mhm.
This is something where, if you know security scanning, right, then usually you have this additional scanners, and they scan either in your repository, in your build system, or even in the IDE. They can even scan containers. What they don't do really good is scanning in production, because if you do it in production, you have to use the JVM instrumentation API, and then you attach an agent, and then callbacks involved and all that. Let's say you would like to check every class node. If this is a vulnerable class, then you have to add a callback to the class loader. And every time the class is loaded, you will get a callback from the JVM, and that brings down performance, right? There are some solutions, but they are always at least 10% performance decrease if you run that in production. This is why companies don't do it. And even companies like SonarQube or SonarType, they have SonarQube.
Yeah, but in production, I mean, if you already deployed, you can scan once. You don't have to scan the entire time, because production is...
Well, the production is dynamic, right? So it can drag in stuff at runtime. It's theoretically possible to do that.
with class loaders, what do you mean?
Yeah.
Oh,
So
okay, but this is...
yeah, and people do that. So it's
okay.
So it's really like, but you can't really be sure that in production everything's fine.
But if you have immutable infrastructure, where you just ship one image, there's no way to change production and nothing is downloaded, then we don't need it, right?
Yeah, then not. But
Yeah, exactly.
if you do, then and there's one other part of it is, what we do is the JVM loads the classes anyway, so that it knows exactly what classes have been loaded. So the big advantage here is that we can tell you, even if you have a transitive dependency on, let's say you drag in a library, and this library drags in log4j and with a log4shell issue in it. Then usually if you have a CI/CD scanner that says, you can't deploy because there's a vulnerable version in there, we can tell you, yes, you have a dependency that is vulnerable, but you never loaded it, because the JVM knows if it was loaded or not. So we can tell you you're still safe. And some products have these problems because they rely on other libraries that have vulnerable dependencies, but they don't use it, and then they have to prove it, because otherwise they are not able to do deployment. With this one, you can do, and in production, we can tell you, okay, you never use the code, so you're still safe, but you should update the dependencies.
This is the code inventory, right?
This is the Azul vulnerability detection. The code inventory, it's basically the same thing, but the way around, because when we know what we loaded, we also know what we didn't load. So then that means we can tell you in production, you know what, you run that stuff for 6 months, you never touched this code, it was never loaded. So maybe you can get rid of it, right? So you can save money and time for maintenance of.
And this is huge, because what we did in the past, for a bank, they wanted to migrate an old project to a new environment, and they were not sure what is actually worth migrating, right? Which functionality is used and which was not used. So what we did in production, we set up one node of WebLogic back then to run code coverage. So it was set up with Jacoco, which is a little bit dangerous, because it could it consumed a lot of memory. It could break, but because this was one additional node, the risk was somehow okay. Yeah. And then we loaded the code coverage report, the Jacoco exe, to IDE, and we exactly saw after a while what was used and was not used. A little bit dangerous, because we could still have some batch runs which runs once a month, but we knew that. But this was good enough. So we said, okay, we port first. At least the priorities are good, because we migrated whatever was to migrate, and we left the black parts. And you are doing this, out of the box, right?
Yeah, this is in the JVM. You get an additional tool that you have to install in your infrastructure, and but the JVM has to talk to someone, right? This is this tool, but in principle, this is coming out of the box, and this is supported in both versions. So this is in Zing or Prime, and also in Zulu, which is called Core now, but Zulu and Prime.
How is Zulu called?
It's Platform Core and Platform Prime.
Core.
But people know it as Zing and Zulu. So if we
but for me, it's also interesting, because talk to customers, that I know.
Yeah, so it's Core and Prime. So these are the official names, where Core is Zulu and Prime is Zing, and both support both of these features. So it's they have both code inventory and also vulnerability detection.
So what are the Zulu or core features? Were the inventory, right? And the security scanning.
Exactly.
How is called the product security scanning officially? No,
The short is AVD, which is Azul
AVD.
Vulnerability Detection.
Okay.
Yeah, but this is
Are these both features, or is there more which I can activate if I have Zulu?
and we have a build with crack, but this is more or less what is available in Zulu. These are the features. Prime has more. Prime has also so-called cloud native optimizer.
No, we will speak about Prime in a moment. But in Zulu we have crack. So one question is in OpenJDK the hooks are defined, but does OpenJDK actually implement crack, the vanilla one? No. I need a Zulu or I need Corretto?
Yes, exactly. Corretto doesn't have. Corretto has a different build. They have a different version of. It's not crack. They just use the same API.
Yeah, they use Snapstart, but it's similar technology.
Yeah, that's true. The idea is the same.
And Cryo is in IBM case, right?
It's also in our case. We also use Cryo. In IBM, in the Samaru, it's called Instant On. But
Instant On.
Mm-hmm. It's more or less the same.
But what interests me, but it has to be supported by the JDK or by the JVM.
Yes, that's the main idea. So what we did,
which JVMs support that?
At the moment, it's Zulu, and I think Bellsoft created a build.
And IBM, right?
IBM has a different one. This is not really the same. They created the same thing on their own. So it's
similar technology to crack. So I mean, which JVM supports similar technologies to crack? This is the IBM Cryo or whatever. Instant On, you said? IBM's OpenJDK?
Exactly.
Then Zulu and AWS indirectly, because I think it's only available on Lambda. I don't think you can use it outside.
It's the same idea, yeah, exactly. These are the ones that support it. Mm-hmm. And how it works is we made it an OpenJDK project. So and this is what people don't really get, right? I say it's an OpenJDK project, doesn't mean it's part of the OpenJDK. Mm-hmm. This is like Project Jigsaw that was an OpenJDK project for years before it became the module system. And so it's the same with crack. It's an OpenJDK project. You can find it on the OpenJDK page. But we probably will try to create a JEP and then make it really an official part of OpenJDK. But this is a process that takes some time. And then every JDK could do it and then it would be part of every build, right? At the moment, it's just with Zulu. Mm-hmm. Yeah, which is quite interesting because it's not really like... it's not an alpha version or beta version or something or pre-built. This is the official, fully supported JDK that comes with crack support. So you can use that. Yeah.
So if Zulu supports crack, right? So I could use Zulu.
Use that in production, and if you run into problems, we will support it. So this is.
Oh, another question regarding support. So if I download, let's say, the latest Zulu version, I put it to production and run it, and then I would like to have support. Can I just call you, pay you the money, as you mean Zulu, Azul systems, pay money and say, I would like to have support for this Zulu JDK, or there is different download? Because at the end, what happened was some companies, we run the open source version, and in order to get support, we had to download something different, which was annoying. But we could actually start with Zulu and then pay you, and we get support for Zulu, right?
Yes, there's no difference. It's the same version. So you get the free version, and if you then decide we need support, you can stick to it. It's the same.
Okay.
You just get different updates then, because then you can also get the CPU updates instead of the PSUs. Mm-hmm. So
this is then business, so they can figure it out. But from the
there's no need to download a different version. It's the same version.
Okay, that's very good.
It's the same.
That's the platform core.
Yeah.
Have we covered everything? So we covered the crack, we covered the AVD, and we covered the inventory, right?
That's for platform core. Yeah. For Prime, there's one other thing that we
and one for the core. The last thing, if I activate the crack and I decide to do that, there's like a flag in the JVM.
No, at the moment you have to download a different version. This is the reason is because it is not part of the OpenJDK.
Yeah.
So we have created a separate.
What's the name of the different version?
Oh, it's just Zulu plus crack. If you
Zulu
go
plus
to
crack, okay.
There is in the downloads you can select JDK plus FX with JavaFX, or it comes with crack. You can.
And how I can tell Zulu to optimize, or there should be a signal, or how it happens?
For doing the checkpoint, you mean?
Yeah.
There's you can use JCommand from the command line to do that, and then it comes with a command where you just say JCommand. Either the PIT, because it's only supported on Linux, or you can also use the jar, and then you say jdk.checkpoint, and then it will create the checkpoint for you.
Okay.
And then you have to implement this resource interface that will lead. But this is the idea is you can also do it by code. So I think the instant on thing from IBM is only by code. They can't do it from external. we can also create a checkpoint from the outside. So you can just tell the JVM, create a checkpoint right now.
Yeah, outside is more interesting because if you have the CI/CD pipeline, usually you would like to run it, and then some pre-warming or pre-training, so you could run the system tests.
Exactly,
So and then you can this is from code. The JVM sometimes doesn't know when the training starts and when it stops, right? So
exactly, yeah. So we're also working on some kind of metrics that you can figure out. Maybe the JVM could figure out when is a good point in time to create a checkpoint, because it loads all the stuff. So it maybe knows, you know what, I probably load 80% of all the classes and optimized it. So maybe now is a good time for a checkpoint, but this is not done yet. So this is just work in progress.
And where are the optimized images stored?
It's up to you.
Okay.
So you can decide where you would like to store it, and that's when you start your application with crack support. Then there is something where we have a flag -XX : and then crack checkpoint 2, and then you equals, and then you put it whatever volume or folder, and then when there is a checkpoint, the JVM will store it in that folder, and then you have a defined folder where you have the checkpoint. When you restore the whole thing, then you just type in Java -XX : crack restore from, and then you point it to the folder. If it founds a checkpoint, it will just restore it from there.
How big is usually the image? You have that experience?
I have some examples. It depends, because this is more or less a heap dump. So what we do is we compact the heap, right? And like with the garbage collection process, and then the compacted heap will be saved in this checkpoint, right? This is the idea. So it's more or less a heap dump. So it depends. If you have a large heap, the files are bigger. If you just have some microservice thing, then the heap might be maybe 50 to 100 megs, something like that.
So it just depends on the RAM settings. So
yeah, exactly. So it's not really huge. But like I said, if you run huge heaps, then of course the checkpoint will be bigger. Yeah.
And what is the performance gain?
Oh, this is huge. I mean, if you start a Spring Boot application, for example, a standard one, then it's maybe around 4 seconds. If you use Crack to do that, then it's 40 milliseconds to start the application.
This is also my experience. I only have experience with Quarkus on Lambdas, and it is twice as fast. So
it's really fast. So I mean, Spring 6.1, it's the next one, and Spring Boot 3.2, if I'm right, they will get fully support for Crack. So that means, and they come with some nice feature, because I talked to Jürgen Höller from the Spring team, and he told me what they implemented. The framework takes some time to load. They have something like checkpoint before start, something like that. And that means they load the framework first, then they create a checkpoint, and then they start your application. That means you as a developer, you don't have to do anything. And that already saves 80% of the startup time. So that means the Spring startup will, just by using Crack, will be 80% faster than before. And you don't have to touch your code. If you won't go further, then you can create your own checkpoints for your application and then create a checkpoint later on and restore from there. But maybe that's not even needed if the framework itself is faster.
But this is always the case, because on Quarkus and Lambda, what happens is if you deploy with snap start on, what happens is this AWS starts the Lambda and it boots Quarkus actually completely. And then it freezes. So the framework is already optimized. And on Lambda, this is constraints. What I do is in a static block, I'm, for instance, preloading the AWS SDK, not my code, because, the DynamoDB and S3 and all this stuff. This is huge. And then I'm basically done. The classes, they don't matter a lot. So sometimes what you can also do, you can load configuration or something which is static. There's also a trick, and because in Lambda is different. We work with ugly code like static, to be even more efficient a bit. It is a little bit different. But you are right. The difference maybe in Lambda that we know when it optimizes, right? Because if you ship it, the optimization happens for us automatically, and then and then afterwards the Quarkus is not booting anymore. We just get the ready-to-use application.
Exactly, and that's the same with the Spring Boot and Spring support in the future. So they added that, and that will help a lot with startup time of Spring applications.
How fast Spring boots without the optimization? Do you have experience? Because I got the question a lot. I don't use Spring, so this is strange, but I use Quarkus all the time. So Quarkus is crazy fast, but people ask me, can we do this with Spring Boot? I say I have no idea, because
yeah, you can, but it's usually the actual versions. If you just use the standard ones, are really 4 times slower sometimes in startups. So it could be, let's say, if you have I use Micronaut a lot, so which is very similar to Quark. So if you have startup times of 1 second with Micronaut, for example, then it's 4 seconds.
Then it's not usable.
Yeah, so it really, and like I said, when they use or support crack, that will be faster, so they can go down to the same.
But with use Micronaut with crack is even faster.
That's true.
and what I mean by that, if it's even faster and Micronaut starts in half a second, what this means then, we don't need native optimization.
That's true.
What happens then is then we can use stock AWS runtime without any fiddling, and you get the full support and no additional stage in the pipeline. So this is actually huge.
Yeah, and you stick to the JVM, right? Which is it is fast. This is just fast. I mean,
it is faster right now, right? Because of the dynamic optimizations, it is faster right now than Graal. To my knowledge, is 10%. So if it's 10% faster, it's 10% cheaper.
That's it, exactly. And this is only if you use GraalVM. If you use GraalVM Community, because GraalVM is not really free, right? Just for 3 years. And then it falls back to the OTN license. And then it might cost you something. So if you use GraalVM Community, which is free, and it stays free. But this is even slower. This is just maybe 60% of the JVM. So if you use that one, it has a fast startup, but then you really don't have the performance. But this is the free version. So you have to, performance is not for free.
No, but with performance, you can save money. And with the money, this is the business decision. You can buy support for Graal Enterprise or Zulu Zinc or Prime.
Yeah, true.
Cool. So exactly, and this crack, which I can never remember, is coordinated restore at checkpoint. I always say restore at checkpoint crack, and in OpenJDK defines basically the 3 hooks methods, right? This is before checkpoint, after.
It's just 2. It's just before checkpoint and after restore.
And after restore, exactly.
Yeah, 2. Exactly. Which is pretty simple. And Amazon, they took the same. We created a library because it's only for Linux, right? If you run it on Mac and Windows in your IDE, because you don't have a JVM that supports crack, it will break. So the IDE will say, don't know the packages. So we created this library called org.crack. You can add it as a dependency. And then this library will figure out if it runs on a JVM that supports crack. And if it does, then it will call the resource interfaces. If not, it will just do nothing.
Cool.
Then you can code on Windows and Mac. And once you deploy on a Linux system with crack, then it will use it. So if not, it won't fail. It will just start normally.
Okay.
So this is and this is the one that was implemented by Spring Boot also. And also even the IBM guys use it in Open Liberty, which is their application server. And they use it with Instant On. They use the org.crack to have the same API internally. So it makes sense to have just one interface everywhere, right? And
this is if you search for OpenJDK crack, you will find the library. This is also what I used. I didn't know that it was created by Azul. I thought this is I don't know who created it, but
yeah, we did that. So if you go to GitHub/crack, there you will find all this stuff. We have examples there. The org.crack library is there. And
so who was the driver behind crack? Was Azul? Was the
it's Azul. So we created that. I think it started 3 years back, and it was, first of all, it was just an idea. Can we do that? And then we figured out, we did some tests, and it worked out quite well. And so then we decided to let's make an OpenJDK project out of it. So that means it's for free. You don't have to pay for crack. Even if you use the Zulu build, then you get it for free.
Now Prime, which was Prime Zinc. So if I don't download Zulu rather than Core, I would like to download Prime. What's the name of the thing? Is it Zinc or Prime if I have to download something?
If you download, then it's Prime. And if you take a look at the JVM type Java version, it will tell you Zinc.
Okay. So
but it is Prime. That's the name.
The package is Prime. So what I get then? I get OpenJDK with replaced compiler, right?
Garbage collector. Yeah, that's what you get. And then you also have the ability to enable Ready Now if you like. And there will be support for crack. It's not in there yet. And also this Azul vulnerability detection is in there. So you can also use it with Prime.
But compiler is confusion. We are not speaking about Java C compiler. We're speaking the thing which picks the bytecode and then does some optimizations to translation to machine code. So this is like the
JIT compiler.
The JIT compiler, the entire thing, the artificial AI almost, right? This is actually hotspot was not high-level statistics, which is nothing else than AI, actually, right?
It's really interesting. All the optimizations. I mean, you can read for hours in these kind of things. It's amazing what the people are able to do. So I really have the biggest respect for the compiler people because they really do amazing things.
Yeah. Yeah, but because they have assumptions, they optimize something and then reject the optimizations. It is back and forth, and and there are, and now with the project Layden, and when they will be able to do some. You can even decide when the optimization happens at the
Yeah.
beginning, to optimize the throughput, or later to optimize the startup. So this is high tech, right? So I would say this is a really cool technology. What happens in Java, and is
It
somehow
is.
invisible from outside, which is a bit.
And also unknown to many people, which is interesting. I mean, you don't have to know it. To be honest, you shouldn't have to know how it works under the hood to code it. But it helps a lot when you write code that should be performant or you have memory restrictions. It's good to know how it works, because
Yeah,
then
this
you
is. Yeah.
optimize the code in the right way.
But if you have in the garage multiple cars, right? You have to decide whether you go to racetrack or just to do some shopping. I mean, this is exactly the same. If I can drive, right? So, but now I have to decide what I'm optimizing for, right? So
Exactly.
exactly.
But I figured out that many people don't even change the garbage collector, so they just use the default settings because it works.
This is also what I do. If there is no requirement on my server, I'm too lazy. It should just run.
Yeah,
On my
and
CLI, you have no flags. I don't like to see them. I'm interested in the baseline performance.
I totally agree. If this is for the standard use case, makes
Yeah.
sense.
And then you should measure, right? You say, okay, now in production. So if we optimize here, how much can we save?
Exactly.
And what I tell management, my product owners, whoever, always, I say, look, this is your job, right? I can spend now 2 days fiddling with it, or you say it's not worth. So we'll lose probably this amount of money, and there's no optimization. It's also a business decision, actually. How much should we spend with optimization, and what is the gain at the end, right?
I was surprised that not many companies, or at least it seems like the feedback that I get, it's not many companies really care about this kind of things. It's like, we just use the standard. Always. Oh, okay. If it works for you, it's fine, but maybe you should check if you can get faster and then save some money, right? And so it could make sense. It depends on the use case. It's not for everyone, but for some people it makes sense. So, for example, there's this one garbage collector, which is Epsilon, right? Which is no garbage collector. So it doesn't do any garbage collection. And if you know exactly the amount of money that your application or service needs, then you can run it without any garbage collection.
I thought already about in my serverless case, right? But because
if you know it, then this could be really good, right? So it depends. But this is first you have to know that this stuff exists. And this is what people sometimes don't even know. They just say, there's garbage collection in Java. Okay. There are different garbage collectors. Oh, I never heard of it. So this is what I see quite often. Yeah.
So the Prime is the real product, and what I could optimize right now is there's the ready now. What I understood is it optimizes upfront. It learns in advance just by compiling, and then we get the peak performance immediately.
Yes.
And combining with Crack, we get the peak performance really immediately, because then it loads everything from an image. Right now, it has to compile, and then the optimization kicks in.
Yeah, and then we have also this so-called cloud native optimizer. So that's like, if let's say you have a service environment where you have microservices, for example, and you need to scale out, right? Quite often. Then the problem is that every service comes with a JVM, and every service has to go through interpretation C1, C2, and so on, and do all this stuff. So just imagine you put the compiler, which is very fast, which is Prime, you put it in a Kubernetes cluster in the cloud and give it some scalability with lots of CPUs and memory if needed. So now you start your service. First time you start it, the service, instead of compiling locally, it calls the compiler that is in the cloud and said, do you have the compiled method for this or the compiled code for this method? If it is the case, it will directly get back the compiled code. So the highest optimized code. If not, it will do the compilation and keep it in the code cache in the cluster. So that means when you scale out a service, then it might be, for the first service, might be slow. The next time you call it, you will directly get the compiled code back instead of compiling locally. And that can really help by scaling out. It can be really fast. And as we already saw that I/O within a cluster is not really a problem in the cloud. This is not the problem to ask the cluster for the compiled code. It's quite fast.
It would run in your account locally in your cloud, not talk to Azul outside the cloud.
No, it's in your own cloud. You can deploy it in your own cloud environment and then use it there.
Because what you could also do, right? Because this is a little bit privacy problematic, but what you could do, you could have a central instance and say, okay, for Cassandra workloads, we find out that this optimization could be interesting.
Mhm.
And you can learn, because the compilers could say, okay, for this method combination, I found this out, report to your mothership. Mothership says, okay, I learned from that. And the next time I already know, then you can pick this. But this is a little bit problematic because...
that's a security thing.
because the enterprises could... But you could do this for open source project and learn from them, right? You could have your own cluster, just run it, and gain experience just by running your toy workloads and learn over time. This would be interesting AI project, right?
Yeah, that's true. That's an interesting idea to do that. So that would be possible, of course. I mean, because you just have to, and this happens in principle because the compiler will tailor the optimizations for the workload, right? And then we'll keep it in their code cache, and the cluster will keep it all the time. So this is like the memory, the brain of all the JVMs is the cluster compiler. And then you can just talk to this guy and he will give you back the code and will also further optimize. So if the workload changes, the compiler will also adjust. This is the whole beauty of JIT compilation, right? So it's more dynamic. So it's not this AOT compiled code, which is you compile once and run forever, but you can compile it every time and optimize it further. So which is a big difference here. Yeah. And this is the thing that we didn't talk about. But then I think we covered all of the features in Prime.
Yeah, cool.
Which is more or less, I think that's it. It's the whole Christmas tree.
And interesting background, right? Started with hardware, and now we covered all the software, equivalents of the Vega back then, Vega 1 and Vega 3. Cool, we covered everything. Get it?
Yes, I think so.
Perfect. It was nice, to cover what you can do beyond the standard, right? Because we always talk about JDK and standards, but everything is nice. But if you can save money or CO2 or whatever you like to save, I mean, you can leave the standards because in worst possible case, you will fall back to the baseline. And then you can also, this is actually absolutely, I would say, fair business, proposition that you can say, okay, you can just stick with Java and you do a little bit more. This is proprietary, but you will save money.
And it's still TCK, so that means you can really drop in, replace existing OpenJDK distribution with Prime. Even if we have this additional compiler and garbage collector, it won't break the TCK. So that means it's fully compliant to OpenJDK stuff. So you won't really run into problems like, you have this other compiler, but it can't compile this code. So this is for sure that you can do that, which is also quite helpful.
Yeah, cool. So it was a nice chat again.
Yes, it was.
Where people can find it. So Azul system is azul.com, I think, right? This is where
Azul.com. Yes, exactly.
And they should search for Core and Prime, and there's a products I already sorted, so you will find all the products we talked about today.
Yes, exactly. It's in the upper left corner. You will find everything that we do.
And you have a blog. This is Harmonic Code, right? With all these.
Yes, but I didn't really blog a lot recently.
But still, you will find some JavaFX UI and stuff like that. And
it's mainly JavaFX stuff on there. And
you are HansSolo _ on Twitter or X, and HansSolo without the underscore on Blue Sky.
This is correct.
Okay, thank you. Was a nice conversation, and I would like to invite you back to, if you have something from your talks or whatever, we can talk about best practices, for instance.
Yeah, sure.
Always nice, and I'm glad we covered Azul. So
yes, I think we covered all that we have.
Thank you.
Thank you.